Hello again, it's Ed Forrest. I want to thank several thousand of you who have been following me for the last 20 or so years. Recently, the Light Brigade and Fluke published some very excellent information regarding the new IEC standards. Um, what both Fluke and Light Brigade Microcare confirm is what we've said all along. The number one cause of failure is a soiled connection. Fluke did a really excellent job, and I encourage you to take a look at their website. I've noted it here. Fluke did an excellent job of discussing the key changes in the IEC most recent document. But there's a caveat here, and the caveat is that generally debris outside of the limited field of view doesn't cause a problem. What we're going to talk about today is what happens when there is a problem. When cleaning doesn't work, do we replace or do we clean in another way? As those who are following me have been aware, I've never been comfortable with the IEC definition of an end face. Prior to 2022, this was the way we looked at it. Um, 4 zones. Now, what has happened is that the 4 zones have been reduced to 2 zones. And Fluke does a really good job of explaining why this happened. So, what's missing? I've always considered that the connector surfaces are 3 dimensional and exceeding, let me be clear, IEC 61300 3.35, all of the additions and the IEC TRs are very important. They're critical. Without them, the promotion of cleaning and inspection would be non-existent. What I'm talking about is a future-proof best practice. What happens when cleaning doesn't work? Do we simply discard and replace? Or are there methods and procedures that can expand on IEC? To do this, I include a Zone 4, which is the total horizontal end face. Zone 5 completes the 3 dimensional structures, as we're seeing here on this SC. What's missing is the concept of cross-contamination. IEC took a major step forward by confirming the need to inspect what I've called intersurfaces, the spaces between fiber. And I think they're also talking about alignment ports. If the alignment port is contaminated, then there's going to be a misalignment. IEC still does not seem to recognize contamination on adapter shells, how this can cross-contaminate, and alignment sleeves. All of these surfaces are critical because we haven't trained, we haven't created the awareness with the technicians, and we haven't uptrained our trainers. What's missing is what we've seen in Bosch and Lomb Nikon benchtop microscopes for years. These images with the RMS-1 Mark II. What's missing is the understanding that debris may exist outside what can be seen by ICC standard inspection. Upper right, there is debris on the zone 5, obviously. That's an eyelash. But there's also dust outside of the field of view on the vertical ferrule. What's fascinating about the image in the bottom left is that that is a fluidic debris. That fluidic extends beyond even the 4-zone perspective of IEC out to the outer edge. And since that's a fluid, when those connectors are mated, that fluid can compress and be moved from the zone 4 into the transmission fibers. What's missing is awareness. What's missing is the need and the fact that there are tools that are available to clean the surfaces when necessary. The Fluke document talks about cleaning multiple times, possibility that the debris cannot be removed. Well, the reality is that the actual procedure may not be removing the debris. It's not that it cannot be removed. It's what we talk about as the cleaning method. Wet to dry, for example. Solvent selection, for example. What is the cleaning material we're using, for example? These are examples of tools that have been created to clean the various surfaces. So what's missing is awareness, the tools that are available, the proper training, and the need to create a toolbox. We're not going to clean all of these surfaces every time, but we might want to consider cleaning the surface when replacement is cost prohibitive. And that's my message. Don't dispose of a perfectly good tool, circuit card, jumper when proper cleaning will do the job. Right tool for the job. Need more info? I'm bumping up against the time limit here, and most folks say that the attention span is only about 2 or 3 minutes, and I'm pushing up on 8 or 9. If you need more info, if you want to talk about it, please give me a call. I'd very, very much like to engage with your organization to help you look into the future. Fluke, Light Brigade, Microcare, Chemtronics, American Polywater, these folks are doing a lot of good work to advance the science, but we're limited because the standards are shrinking what we should be looking at. We need to be considering the surfaces as 3 dimensions. Thanks. Give me a ring. Take care.